Hello all. So today we are going to see about the topic which is what do you call that mechanisms. So in continuation with the previous lecture like kinematic links and kinematic chain, since we already come across that basics of kinematics and basics of mechanics. So in continuation with that, we just go and see what are the mechanisms are there with respect to kinematic chains and links, how it has been worked and what kind of chain kinematic chain it has been adopted. So in this way we just see in detail in this session. Here mechanism is nothing but generally it is a combination of links which do the kinematic action, which means it transfers the motion from one link to the other link. With the help of that what happens, the motion will takes place. Okay, so that motion is what do you call that mechanism. Okay, so here generally when we call that links are called mechanism means only when there is a link, when one of the link has been fixed at one point, that point is what do you call that mechanism. Okay, so let us take a four-wheeler mechanism, let us take an four bar link and as well as quadratic chain mechanism. So in all aspects here you just take any kind of points, at least one of the link has been taken as an fixed link. So in this session we just see in detail how many links are fixed for a single mechanism. Okay, so if you take it, there is a simple mechanism, at least one of the link in 4 has been fixed. That is what you have seen in the screen. So in case if it is a complex mechanism, we having more than one link has been fixed. It has more than either it may be a 2 or more than 2. Okay, so you just see there is a ternary mechanism in this point, and here also you have seen the quaternary mechanism. So in this way it has been all has been interconnected, but it having more than 2 or 3 kind of mechanisms are there. So that is why the fixed points has been keep on varying. That is why it is called it as a complex mechanism. Okay, so let me see in detail about this more in this session regarding this. Let us take the spatial mechanism. If you take a spatial mechanism, so in this spatial, you just see that drone is one of the good example for the robot. On this drone, we having the mechanisms which has more than 2 or 3 links has been fixed. This spatial mechanism is generally lie in different kind of planes which is not available as in the same plane. So that is why it is called the spatial mechanism. A good example for this is parallel robot is there, and also various types of links also has been connected with this. Okay, so that is why the robot has been taken as an example. And here when you call it as a machine, mechanism is not all mechanisms will be considered as a machine. At the same time, not all machines will be taken as a mechanism. Okay, so the generally machine is nothing but it is a combination of mechanisms which produce the desired output, so that the desired output which will be called it as a mechanism or otherwise machine. Okay, so that is what this machine here. It is the one of the link has been fixed with the mechanism which transfers both the static and as well as the dynamic forces. So that is why this is called it as a machine, and similarly the motion takes place between these two has been varied. Okay, so they are this is the basic comparison which takes place in various kind of aspects which has been compared. So let us take how can we calculate this kind of degrees of freedom when there is a different mechanisms are there. How can we calculate and justify about those one? So let us take this example. Generally degrees of freedom is nothing but the mechanism which can able to travel, or it can be travel more than 3 or 4 different kind of directions. There is no restrictions for this movement of the mechanism. That is why we use it to call it is a degrees of freedom. So with respect to the space of one of that planes, here on each axis it having one linear motion and as well as the rotary motion. That is why it is called it as the degrees of freedom as more than 1. So this 1 degrees of freedom has been calculated in accordingly. Here these are the lower pairs and standard values of degrees of freedom with respect to that mechanism rotation and the motion. So here the number of inputs has been given with respect to the motion, and this is the basic formula which has been designed by the Guchberg criterion. Degrees of freedom is n is equal to 3 into L minus 1 minus of 2j and minus of h. Here L represents number of links, J represents binary joins, and H represents number of the higher pairs. And based upon this equation, the mechanism has been determined whether it is able to transmit the motion or not. Here this is the determination of formula. Okay, so with the help of this formula we can calculate the degrees of freedom for the each links that you have seen in our mechanism. A, B, C, D is one kind of links which has been attached with the total 5 number of links, and we having a joint is 4 joints are there. Oh, at the same time, with the help of this motion, how much it has been transmitted. Here L is equal to 5 and J is equal to, there is a 2 plus 2 into 3. We know that formula 3 by 2 into L minus 2. So using those formula, we just simply apply here. With the help of this, we can find out the degrees of freedom is 0, which means there is no motion takes place in this. So that is why the degrees of freedom is considered as a 0. Wherever, in this case, in the second category, the degrees of freedom which has been, here we don't have any kind of higher pair, but at the same time, it has transmit the motion, that is why n is equal to 2, which means the degrees of freedom has 2 different kind of motion. So with this, I just go and wind up, and thank you for your patience to listen this lecture.